Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's challenging level puzzle, and it's called Sum Assembly Required by Jonesy. And here are the rules. Hello Jonesy. We have standard Sudoku rules apply, which means each row, column, and 3x3, each row, column, and 3x3 box must contain the digits 1 through 9 exactly once. Each cage has a 2-digit total to be placed by the solver inside the cage. Okay. And we need to place the tens digit in the leftmost cell of the topmost row of the cage. Then write the total from left to right. If the cage shape doesn't allow a left to right placement, write the digits from top to bottom. So that would be this example, right? So the sum of these digits must be written starting from the leftmost cell of the top row of the cage. So for example, you could write it here and it would go this way. This would go this way, and if cage shape does not allow it, which is in this case, and in this case actually, then you write it from top to bottom instead. Okay. So, and each cage has a 2-digit total to be placed. So that means each cage is summing up to a 2-digit total, guaranteed. So you place the tens digit in the leftmost cell of the topmost row of the cage. Then you write the total from left to right, and if you can't go left to right by the shape of the cage, you go from top to bottom. If the total consists of two identical digits, for example, 22, 33, or 44, write only a single digit. Okay? Digits may repeat within a cage, provided standard Sudoku rules are not broken. And in fact, in this case, it has to repeat, actually, right? In this case, it also has to repeat. Because you have 9 digits here, and you have only 9 digits possible in the puzzle, so these two have to be repeated. And digits along an arrow sum to the digit in the attached circle. So these two digits must add up to this digit. So for example, you have 3 and 5 here. This would have to be 8. So say this sum here was 54. Then this would have to be 5 here and 4 here, because this is the leftmost cell of the topmost row. And this is then the ones digit. If, say, this added to 55, you would just have a 5 here, and that's it. Anyways, those are all the rules. If you like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay. So, this is 45 plus 2 other digits. So that could be that could be 40 something. 40 something up to 60 something here. This is 4 digits here adding up together. You cannot have a 0. So this is 1 and 2. This is 5 digits added together, and these two combined must add up to 45. You could have 1 with something here and then 2 with something here. Or 2 with something here. I guess this could be technically 1, right? Can this ever be 2? Because they have to both add up to the sum of the cage itself, right? So say it is 20-something. I guess you could have 22 here. Otherwise, it's not possible, right? Because these two digits can't be 20. So this still could be 1 and 2. But it would have to be 2 by itself, so it would be 22. Ah, but that doesn't work, because if this is 22, this has to add up to 23, and you can't have a 2 here. So I think this has to be a 1 then. So this is 1, and this is 2 or 3. So this cannot be 11. So we have another digit here. Therefore, these two digits add up to... Oh, these 3 digits must add up to 10. Right? The problem with 20-something is that it would be 2, 8, and 9 at most, which adds up to 19 only. Plus the other digit's never going to add up to 20 plus that digit, right? But this has to add up to 10. And then this digit is the same digit, right? Because it cannot be 11, because if it's 11, this can't be, you can't have, it would have to be 1, 2, 3, and 5. Which doesn't add up, which cannot add up there. So then this must be 9. And this has to add up to 10. So you have 2, 7, 3, 6, 4, 5 here. And these add up to 10. And so this is a singleton there. So this is if you have 12, you could have 33, so that's possible. If you have 13, this would be 22, and that's possible. If you have 14, this would be 31, which is not possible. 15 doesn't work. 16 gives you 29, which doesn't work. 17 gives you 28, so that's possible. 18 So we know then this is gonna 18 plus 27 works too. So 4 and 5 do not work. 14, that would be 14 and 31 here. And we already have a 1 in the box. 15 and 30 obviously doesn't work. If you have 12, this is 33. If you have 13, this is 22. No, that doesn't work. It would be 32, so this can't be 3. So 12 works with 33. 17 works with 28. And 18 here works with 27. Either way, you cannot have 2, 7 here. Because either this is 12 with 3. So this is guaranteed to have a 2, no matter what, right? Which means this cannot be 2 and 7. However, I think it could be 3 and 6. Yeah, it could be 3 and 6 here. Okay. So this has to be 1 or 2 here to add up. And if it's 1, that doesn't really work. Sorry, if it's 2 here, that doesn't work. Because these two would have to you have 20... You'd have 2 here, and then these add up to 17 at most, which is 19. So this must be a 1. And it must be with 9, adding up to this singleton digit, right? Because these must be added up to 10, which gives you the 10s digit, and then this is the 1s digit by itself. So this has to be 9. So this is something plus 9. And this is also 2 or 3, right? Because, right, so then this is 2, again, 2, 7, 3, 6, or 4, 5. If you have 12 here, then this is 33, and that works. I think it's the same thing, right? 12, 13 gives you 32, which is not possible. 14 gives you 31, which is not possible. 15 gives you... so this has to be 2, right? 15 gives you 30, which is not possible. 16 gives you 29, which is not possible. And this is 7 or 8. So this cannot be 2 or 7 here. So this must add up. It's either 40-something or 50-something, right? It cannot be 45. Can it be 55? No. So we're guaranteed this digit has to be not 1, 2, 3. Cannot be the up. It could be 4. It could be 54. Or it's 46, 7, 8, or 9 here. Interesting. This is either 30-something or 40-something. So this is 34 or 40-something. It could be 44 here. This is 3 digits, so this is 1 or 2. And then this is down. This is at most 9. Because it adds up to a single digit. So 45 minus at most 9 means this is 3 or 4. 5 digits. Could be 2, could be 1, 2, 3, 4. Can it be 4? It can't be 4. 1, 2, or 3 here as a single as the digits. This is 35 plus 9 at most, so that would be 4 at most. It could be down to 1, though. Okay, this is 3 digits which add up to a single digit, so this is 6, 7, 8, 9. And these have to be 1 through 6 at most. Okay, what does that mean? What digits can be here? I think everything but 5 works here, right? 3 does not work here. If 3 is here, that means this is 48. This adds up to 48, but we can't. This 3 would force this to be 4, which would force that to be 5. So 1 works because then it becomes 46. 2 works because then it becomes 47. 3 does not work. 4 does not work because then that's 49, but we already have a 4 here. 5 does not work because then that becomes 50. 6 does not work because that's 51. So 4... Okay. So 1 works, and that becomes 46. 2 works, becomes 47. 3 does not work, that's 48, but the 3 forces this to be 4, and then it can't be 48. 4 doesn't work because then that's 49, and the 4 sees the 4. 5 makes this 50, which doesn't work. 6 means 51, which doesn't work. 7 is 52, which doesn't work. 8 is 53, which doesn't work. And 9 does work as 54. Interesting. So where's the 9 in row 1? It has to be here. So that's 9. Because it can't be here because the 9's in the boxes, and these are all fixed. So I think this is guaranteeing a 4 here, right? Either this is 46, 47, or 54. So yeah, the 4 has to be here. Which means the remaining digits in row 1 have to be 5 through 8. Interesting. Okay. Where is the 2 in row 3? It cannot be either of these, so it has to be one of these 3. Okay. If this is 36, this is 9. That seems fine. This could be up to 3. But if this is 3, that means this is 1, 2, which means this is 42, which doesn't work. Cannot be 4, because then it's 1, 3, and then this would be 41. Cannot be 5, because then that's 40, and that's 0. That's not possible. So this has to be 3. So this is guaranteed to be 3 here, which means this cannot be 3 here. So 6 with 9 works. So it could be 6 and 9. This could be 7 and 8. 8 and 7, or 9 and 6. So those do work. So this is 30-something. If you have a 3, you could be 33 with 6, 7, 8, 9. So that does kind of work. Okay. So what are these sums? If this is 1, this becomes 44, and that's fine. If this is 2, this becomes 43, and that's fine. If this is 9, it becomes 36. Interesting. Okay. Oh. This cannot be 6, 7, 8, 9, because these two digits add up to what that digit is. So this is at most 9 by itself. So this like can't be 9. It's 8. So these sum up to 8 at most, which means 8 plus 8 and 9 is 27. So this cannot be 3. It's 1 or 2 here. Can it be even 10 though? I guess. But then, okay, so if this is a 1, that forces us to be 2, 3, 4 here. To add that up. If this is 2, this adds up to... Okay, so if they say this is 20, then these 4 must add up to 20. And if that's the case, it would have to be... This is guaranteed to be 8 at most. 2 plus 8 is 10, plus 9 at 8 doesn't work that way. So this cannot be 2. This is 1. So this must be 2, 3, and 4 here. Interesting. Which means this can't be 1. So it's 20-something or 40-something. This must be either 5, 6, or 7 here. This is 2, 3, 4, which eliminates 2, 3, 4 in the rest of the box. So this is 5 through 9 here. Interesting. So this is at least 11, which means this cannot be 4. Okay, so this cannot be 20, because if this is 20, the problem is 2 and another digit must add up to 20, which is not possible. So this has to be 1, which forces this to be 9. Oh, it could be 11. Dang it. Okay. Ooh, I forgot about this here, too. So these can never be 11, because the problem is that would force this to be 34? Ooh, okay, I totally forgot about that. So this could be 11, technically. Uh-oh, okay. Let's redo this then. Okay. So again, it cannot be 20 here for 4 digits. It can't be 20 here, actually, either. Right? You can't even have 22, because 8 and 9 at most add up to 17. So this 3 digits is guaranteed to be a 1 here. So this is 1 here, this is 1 here, and this is 1 here. But I forgot this could be 11. This cannot be 11, though, because of the 2, 3 possibility, right? So if this is 11, it requires 1, 2, 3, 5 here for 4 digits. 3 digits is not the same. So therefore, this is still correct. 2, 3. And this must add up to 10 here, which means this is 1 and this is 9. So therefore, we have 9 here. So then this still becomes 2, 7, or 8. If you have 12, that's 33 to add up to 45. 17 gives you 88. 18 gives you 27. So we're guaranteed a 2 here. This is not, though, the same, because you could have 11 here, and then this would be 44. Right. So that assumption was wrong. Okay. So this could be actually a lot more possibilities. Same with this. This could be 22. 1 cannot be here. So 1 has to be one of these two. Okay. That's helpful. If we try to make this 20-something, it can't be 20-something because this is at most 9, and then this would have to be 1. So that's 10. So then you have 12 here, and then you can't add up to 22, and you can't add up to 20 for just these digits. So this is at most here 17. Oh, you can't have 5 digits adding up to 11. So that's helpful too. So we know this is 1 then. So it cannot be 22 because, again, this is a single digit, or it sums to a single digit. This is a single digit, and it can, so therefore it has to be, this sum must be here. So these 2 digits essentially are the most these could be, which is 17. So if we try to have a 2 here and 17, I guess it could, wait, no, it still could be 20. No. The problem is if you don't okay, so 1 can never be here. We have a guaranteed 1 here, we have a guaranteed 1 here. That means in column 5, where's the 1? Cannot be here or here because of 1's in the boxes. It has to be one of these 3. This is a sum of 2 digits, which 1 can never be for normal Sudoku. So 1 is one of these 2, guaranteed. If we have a 2 here, that means 1 is here, and this is at most 9. So this is not going to add up to 20, 20 plus the number, and it can never add up to 22. Because, again, this is 1 plus 9 at most. 10 plus 8 is 18. So then that would not be 22 plus the 2. So we're guaranteed this is 1. And it cannot be 11 because it's 5 digits. So this must be 2, 3, 4 to add up to 10 with this singleton as the 1's digit. That means we have 5 through 9 here. This is 5, 6, or 7 to be 2, 3, 2, 4, or whatever. That's interesting. Okay, so this is 5 through 9 remaining in box 5. We're guaranteed a 2, 3, 4 here. We are also guaranteed a 2, 3, 4 here, at least. Because we don't have a 1, and it cannot be 2 out of 2, 3, 4 because we have 2 here from 2, 3, 4. That means this is at minimum 2 and 5, so this is 7, 8, or 9 here. It could be 2, 5 up to 7, right? That means the rest of column 1 is 5 through 9. And because, sorry, column 6. And since the rest of column 6 must be 5 through 9, this adds up to at least 12, which means this cannot be 11. So this must be these two must add up to 10 because we have a teen and another digit. So this has to be 9. So this is 9, which eliminates 9 in the rest of the column. Um, can this add up to 11 with 7? I guess, yeah. 1, 3, 7 works. Okay, so let's look at the ones that add up to 11. You could, oh, sorry, it's 1, 3, 7. So 1, 3, 7 works. 1, 2, 8 works. So then this becomes 2, 3, 7, or 8. So if this is 11, this could be 4. So this is 2, 3, or 4. We're not sure. This cannot be 7. If we try to make this 7, that has to be 2, 5 here. But that would make this 3, 4, which would also be 7. So that does not work. Therefore, this can't be 3. So again, you could have 12 with 33, 17 with 28, 18 with 27, or this could be 1, 2, and 8, and this is 44. Okay. So I think the 2 still has to be here then, right? If this is 12, this becomes 33. If this is 17, 28, 18, 27. If this just adds up to 11, 1, 2, and 8, this has to be 44, but this is 2. So 2 has to be one of these two, which means this cannot be 2. So this cannot be 2 or 7. It could be, okay. Hmm. So we're guaranteed 2 here. Okay, so this cannot be 2, 7 either. So 2 has to be one of these 3. Okay. 2 cannot be here, so this must be 2 here, which means this cannot be 2 here. So we're guaranteed a 2 here, so it's either 2, 3 or 2, 4. So that makes this 5 or 6. Okay. This is, again, either 4 or 5 here. So if this is 1, this is 46. It cannot be 1. Okay, so that's good to know. If it's 2, it's 47. If it's 3, this becomes 40. Okay, so then we have the same problem here. This is 3 or 4, right? This is a singleton, adds up to an single digit. So it's this is at least 36. So if this is 3, that would force us to be 4. This would be 48, and we have a duplicate 4 in column 7. This can't be 4, then that would be 49. This can't be 5 because that would be 50. But this could be 6. It cannot be 6. Cannot be 7 because then that would be 52. But it could be 8 or 9 here. So it could be 8, 53 or 9, 54. Okay. Where is 9 in row 1? Can't be here because 9 in the box. Can't be here because of the cage totals that we added up to. Can't be either of these because of the cage totals, so this must be 9 here. That means where is 9 in row 2? Can't be here because of the 9s in the boxes. Can't be here because of cage totals, so this has to be 9. So this cannot add up to 11. Okay, so, well, that was a long, convoluted way of going to the whatever that what I had before, but it is guaranteed now, so that's good to know. That means this cannot be 4 because this can't add up to 11. So now we have a 2, 3 pair, which means we're guaranteed 4 here. And this cannot be 8. This is 2 or 9 here. So if this is 2, this becomes 43. If this is 9, this is 36. So either way, there's a 3 guaranteed to be here. This is at minimum 5 plus 7. It's not even 5 and 6 because of this 5, 6 here. So this adds up to at least 12. Plus 45 is 50 something or 60 something. Okay. We're guaranteed 9 has to be one of these 3. Okay. 4 is guaranteed here, which forces this to be 5 through 8. This has to be 2 or 4 here. Again, 5 unique. Okay, it can't be. I don't think it could be 4. Say it's 4. 4 plus 5, 6, 7. It can't even be 4, 5, 6, 7, 8 because that would eliminate all possibilities for this cell. So it'd have to be 3, 4, 6, 7, 8 at most. Which is 21 plus 21 plus 7, which is 28. So this is 30 something at most. So this is 2 or 3 here. And I think we figured out this has to be 3 here, right? Okay. So we tried, 1 can't be here. If we have 3 here, then this becomes 42, but then this has to be 1 and 2. So this can't be 3, can't be 4, because that's 41 added to that, which doesn't work. Can't be 5, yeah, so this has to be 3. So this is 3, which forces this to be 20 something, which makes this 3. Okay, so this is 20 something. This is 3, which forces this to be 4, which makes this a 2, 3 pair here, which adds up to 5. This cannot be 3 and 6, so it has to be 4 and 5. This can't be 5, no 5, no 5. No 5 here either. Okay, so this has to be 33, which makes this 12. So this is 12, this is 33. That means this can't be 2, this is 2 here. So this is 4 and 5, so this can't be 4 and 5 adding up to 9, so this is 3, 6. This is 17, or this is in 28, or 18 and 27. So this is a 7, 8 pair, which eliminates 7, 8 in the rest of the box. This can't be 6 because of a 3, 6 pair in the box. So this is 5, which means this can't be 5. This is 47, which forces this to be 2 to add up to 47. 7 eliminates 7 here, so this is 8. This is 7. This can't be 7 or 8. It's 6. No 6 here. No 6 here. So this must be 4 here. And let's just make sure. So this should be 2, 8 adds up to 10. 4, 9, 5 adds up to 18, so that adds up to 28. Yep. 1, 9, 2 adds up to 12. This is 7 and 8 here. This 4 eliminates 4 here, so this is 5, which makes this 4. This can't be 2 anymore. Remaining digits in row 3 are 2, 1, and 5, and this can't be 2. Remaining digits in row 2 are 3, 6, and 8. Well, this cannot be 3 because 3 is 1 and 2 added together. Also because of 3 in the column. So this is 30 something. 30, this is again 6 through 9 here, and this can't be 7, so this can't be 8 here. 3 and 5 add up to 8, so that works. This can't be 8, obviously. So 3, 5 add up to 8. 3 and something else, 1 and 2 does not add up to whatever that digit is. So 3, 5 add up to 8. 6, 2 add up to 8. So either way, this is 8. So this is 8, which means this cannot be 8 here. Okay. This is 2. So this must be 43 that this cage adds up to. The 3 cannot be here. This is 6. This is 3. So this must be 3 and 5, which forces this to be 1, which forces this to be 2. Remaining digits in row 4 are 5 through 9. This can't be 9. This can't be 7 or 8. This cannot add up to 6 because we have already a 1 and a 2. Actually, we have a 1, 6, 7, 8, and 9. We have a 6, 7, 8, 9 quadruplet in column 4. So this must be 3, 4, and 5. That means this must be 6, 7, or 8 here, and we're guaranteed a 6 here. So this is either 3, this can't be 3 here. So we're guaranteed a 3 here. This is either 3, 4, 3, 5, or 4, 5, which adds up to 7, 8, or 9. So we're guaranteed a 6 here. This can't be 5 because of 5 in the column. So 5 has to be one of these two. This can never be 65 because 45 plus 2 digits is never 65. So this has to, and again, this can't be 5 and this can't be 5 and that can't be 5. Whereas the 5 in row 4, it must be one of these two. If this is 5, that's 65, which is not possible. So this is 5 here. And this cannot add up to 11 for these two digits, so it must be 59 here. So this cannot be 9 here. That means this adds up to 45. 59 minus 45 is 14, and we're guaranteed a 6 here. 14 minus 6 is 8, so this has to be a 6-8 pair, which eliminates 6 and 8 in the rest of the column. This can't be 8, this is 7, that's 8. And this can't be 7 or 8, so this is 9. This can't be 8 because of 6-8 pair in the box, so it's 7, which makes this 8. So this cannot be 8 here. And it can't be 8 here. So this has to be a 4-5 pair to add up to 9. So this is 3. Okay. So these 5 digits must add up to 20. This is 6 through 9. This is 1 through 6. This can't be 4, 5, or 3. This can't be 3. Okay. Okay, so how does this add up to 20-something? It could be 22 technically. Wait, hold up. 6, 7. Okay, 2, 6, 7. So 2, 3, 4 is 9. Plus 6 and 7 already add up to 22, so that's not possible. Okay. So we know 2, 6, 7 adds up to 15. 3 and 4 at minimum adds up to 7. 15 plus 7 is 22. So that means 22 to add up to 26 or 27 has to have 4 or 5 here, right? 22. So this is either 22, adding up to 22, or 23. 22 to add up to 26 or 27 must have 4 or 5, and it cannot be 4 or 5 because of 4 or 5 in the column. So it must be 5 here. So this has to be 5. This is 4. And this must be a 3. So this is 11 plus 15 is 26. So this is 6, that's 7. This cannot be 3 or 6 then. This cannot be 6 here because it can't be 1, 2, 3 adding up to 6. This can't be 6. Since this can't be 6, this can't be 9 here. This can't be 5 because of 5 in the row. Technically, it still could be 3, 4, 6, 7, or 8. To add up to 7, it cannot be 1, 6, 2, 5, or 3, 4, so that can't be 7. Therefore, this is 9, which makes this 6. 36 plus 9 adds up to 45. No 1, 8, no 3, 6, no 4, 5, so this is 2, 7 here, which means this can't be 2. This becomes a 1, 4 pair here in row 8. This can't be 1 because of 1 in the column, so this is 4, this is 1. That means 1 cannot be here. You can't have 1, 2, and 4 adding up to 7, so this can't be 7. It's 8 or 9. There's no 4 here anymore. We're guaranteed a 2 here. This can't be 2 because of 2 in the column, so this is 7. This is 2. Remaining digits in box 9. We have 1, 4, 5, and 8. And this can't be 1, 4, or 8, so this is 5, which eliminates 5 in the rest of the box. This can't be 4 because of 4 in the column. This 5 eliminates 5 here, so this is a 2, 6 pair. So this is 1, 2, 6 adding up to 9. So this is 9. This cannot be 4 here or 1 here, and that's the only remaining digits in row 9, along with 8. So this has to be 8, which means this is 1, that's 4, this is 8. This can't be 8 anymore. Remaining digits in row 7 are 5 and 7. This 5 eliminates 5 here, so this is 7, which makes this 5. So this can't be 7 here. Actually, I guess we sort of figured that out, but anyways. We have 3, 6, 7 remaining in column 1. If this is 3, this has to be 1 and 2, so this would be 1 and 2. If this is 6, it's either 1, 5, which it can't be because of a 5 here, and it would have to be 2 and 4. So this would be 2 and 4. Or if it's 7, I guess it could be 1, 6, no 2, 5 because of 5's in the box. It could be 3, 4. With, like, no, it can't be 3, 4 because that can't be 3 or 4 here. Okay, so this digit is 1, 2, 6, or 8. Remaining digits in column 7 are 6 and 9. No, 6 and 7. Okay. The remaining digits in column 8, we have 8 and 9. This 9 eliminates 9 here, so this is 8, this is 9. Remaining digits in column 9 are 1 and 5. This can't be 5 because of 5 in the row, so this is 1, which makes this 5. 1 eliminates 1 here, so it's 2, which makes this 6, which makes that 2. This can't be 2 anymore, so this can't be 3 because it can't be 1 and 2 adding up. We have a 6, 7. This 2 eliminates 2 here, so it's 3 and 2. We have a 6, 7 pair in row 6. So this cannot be 6 here. That's 4. 2 and 4 add up to 6, so this is 7. That's 6. 6 eliminates 6 here, so it's 3 and 6. This can't be 3 or 6, so it's 7. This can't be 6, so it's 8, 6, 8. This can't be 2, 6, or 8, so it's 1, which forces this to be a 3. And that's the puzzle. Yeah, other than basically forgetting about the um, double digit constraint, or the double, I don't know, how would I say it? Replicated digit? I don't know. Any 112233 double digit? I don't even know how to. Yeah. I forgot about that in the beginning. Obviously, I accounted for it in box 1, but I did not account for it in box 2. It still turned out the same, but I did not account for it in box 2, box 5, but we dispelled it pretty quickly in box 5. And then with the restrictions here, this would never have to be duplicated, so it had to be 1. Even then, it still couldn't be. I guess it could have been 11, but we dispelled that pretty quickly. So in the end, if I had gone through without checking, it would have worked, but obviously I would have missed that possibility. So it was good that I basically double checked, but yeah, it is what it is. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.